January the 19th, 2026. Guys, you're looking at images of LASCO C3. This one cut off yesterday just before the X-flare, but those images are here now. Let's take a look. This thing's moving extremely fast. 8:18 on the 18th at 8:18 UTC time, the flare left the sun. It's behind that round disk, the occulter disk. The sun is the size of that circle. And a few hours later, we're starting to see energized particles because these are X-ray particles, as in radiation. But I'm not going to use that as a timestamp from the 18:8 or 18th hour UTC time yesterday. But here, the satellite's becoming fully involved, and I did the math on it, and you can see it's now January 19th. Again, everything's universal time to scientists. So 17 hours, it has traveled 92 million miles. Think about that. Now you have what's called L1. It's not quite a million miles from Earth, but it is exactly 92 million miles from the surface of the sun. And that's where this satellite is parked. In other words, it's 92 million miles from the sun's surface. The information is here on the right, and it's called L1, the SOHO satellite. That's for Lagrange 1. It is 92 million miles from the sun's surface. And the operational position, it orbits this L1 point, maintaining a constant, uninterrupted view of the sun for solar studies. Again, Earth-facing perspective. But what I want to do is, because very few of these X-flares have a storm this strong and that you can visibly see. And so I want to do my own math on the speed that it's traveling. But at 17 hours, I put it in here to this chart. At 92 million miles is 2,418 million meters per second. Now that, if you break that down to miles per hour in this bottom chart, that thing's moving at 5,441,000 miles an hour. Now we've seen in quite a few solar storms the solar wind speed get to 1 million miles per hour, or even to 2 million miles per hour, maybe a little more. But 5 million is very fast, and it's already traveled 90% of the distance. So it hasn't slowed, as far as slowing down from, say, muzzle velocity from the time it left the sun to moving 92 million miles. It has not slowed down very much at all, so it's only 1 million more miles from that time there. And this has already been recorded. Anyway, think about that, 5,410,000 miles per hour. There's no doubt that we're going to look at more information, that's going to create quite a solar geomagnetic storm, 4 or higher, and that's very unusual. But again, I'm taking advantage of being able to visibly see the energized particles in this wave that's coming at us. But remember, you got a couple of different elements involved in the coronal mass ejection. One is the protons that are in this wave, and then the photon burst. I talked about that yesterday. It hit us in 8.2 minutes at the speed of light. That's how fast the speed of light is. And so this is what we got, guys, moving very fast. Let's look at the current solar wind speed, and you're going to kind of be amazed at that because of what it just did. It reminds me of just before tsunami, the water at the beach will recede way out into the ocean, like a reverse vacuum effect. That's what we're seeing on our solar wind right now. Let's take a look at that. Now, as I'm reading this and looking at it and talking to you guys, it is 11:29 a.m. Central Time, and this is current information. It's updated, I think, every 5 minutes. Solar wind speeds in the purple right here, in kilometers per second. And we were cruising along here back this is 3 days, by the way. But if you go back further than that, we were around 700. And right now we're below normal. Normal is 320 on a good day, anywhere right in there, 320 kilometers per second. This is a vacuum out. We've dropped now, guys, to 299. Look at that. And you don't see it very often, and it's flatlined. But what is happening as it's flatlining, because I think we're seeing a reverse vacuum, the density, the amount of particles per meter cubed is increasing. That's that solar storm coming in. Now, at the very top, you're seeing our shields. When both are on one side, the shields are kind of closed. This is magnetically. But when you see these purple lines here, you've got open shields. In other words, there's a gap, and we talked about it looking at the magnetosphere images, and it's called the cusp. And it's a gap on the edge of the magnetosphere, guys, our shields. And so we're starting to see that opening occur more and more. And that is not good when you've got an incoming solar wind speed or increased wind speed like that with a geomagnetic storm. So you guys that are susceptible to the effects of this could be hard to deal with. Now, what they told us yesterday, looking at the time, was we could expect impact around 7 p.m. this evening in New York, Eastern time, and then 6 o'clock here. Move over to the West Coast. And what that does is, this time of year, by 6 o'clock, it's dark here. You may have a little glimpse of a sunset, but it's pretty dark. And that's telling me, and all of us, that we're not going to get a direct impact. But West Coast, you're still going to be in the afternoon, earlier, 4 o'clock in that area. And then Hawaii, Alaska, all the way to Japan. It's going to be a Pacific event, most of it. But because of the fault zones travel throughout the planet, an impact on one side can affect the entire planet. But I mentioned the Japan quake many times of 3 X flares plowed into Japan when it was directly sun facing in the middle of the afternoon. And that, again, the Fukushima event. But another thing you don't get to see a lot of is, like, I guess you could call it a space vacuum, or this reverse vacuum from that incoming wave. But now the energized particles that we saw, they move faster. That's the third component. They move faster than the density, the plasma that's in the cloud itself, the coronal mass ejection. And we're already being bombarded by them, even though the CME is not here yet. We're going to see a very fast jump in that solar wind speed we just looked at when that starts to happen. But they're saying a solar proton storm in progress. Energetic protons from the sun are raining down on Earth. They were accelerated in our direction by yesterday's powerful X-class solar flare. This is called a solar proton storm and is currently a category S3. That's the geomagnetic storm currently, right now. But it's going to go to a 4, maybe higher than that. I think they underestimated this one just a little, and that's why I'm paying a little more attention to it. Anyway, shortwave radios inside the Arctic Circle aren't working right now due to the storm. You guys are already starting to feel the initial effects of it, and what you're looking at the bottom is that X-flare. Remember, you had 122 minutes of blackout from the radio signals, and that was from the initial burst that took 8.2 minutes to hit the Earth. Anyway, they're saying shortwave radios are not working right now, which is causing apolar cap absorption event. Now that goes, guys, to ground level currents. And remember in my videos where we talk about CERN and how they're built right in the northern hemisphere to where they are tied into these ground currents. And these ground currents are just inducted into the Earth from our our shields, the magnetic shields of our planet, the reason your compass works. Things. Now, even though we've just got a S3 storm, guys, they are, and that's a proton storm, remember, this G4 class geomagnetic storm is possible. And that's on January the 20th when a CME is expected to slam into Earth's magnetic field. But they're going by universal time. And that's why I used last night to show you that that would be at 7 p.m. And we're going to look at the current information and the current tracking. But this thing is moving so fast, we're already getting impacts from it. Anyway, it says The CME was launched yesterday on the 18th by an X1.9 class solar flare from sunspot 4341, and we watched it, and that is an amazing, long-lasting flare. We talked about that yesterday, guys. That just means that the Earth will be inside of that cloud that was generated over that period of time. 2 hours for the radio blackout, guys. This could go on for a day. Anyway, researchers call it a long-duration flare. The explosion lasted for hours, which makes it even more powerful than its X1.9 rating would suggest, because you can have an X-flare, guys, without the CME. Much of the power went into the CME, now approaching Earth. So stronger than an X1.9, we could visually see it. If NOAA's forecast is correct, the CME will strike during the early hours of January the 20th. In North America, that means the night of January 19th and 20th, again 7 p.m. East Coast. A severe storm could spark auroras visible to the naked eye in at least a dozen northern tier U.S. states. Guys, when they're like this, people start catching them from Alabama. Anyway, photographic auroras with colors visible only to cameras and smartphones could descend as far south as Arizona, Texas, and Southern California. Now, before I change to another screen, I want to bounce back, guys, over to the solar wind speed chart, and it's still flatlined, well below normal. Wow, look at that. Again, the beach going, all the water running off the beach before the big wave hits. That's exactly what you're looking at. Let's take a look at this chart again. In the last video, this flare had not went back to normal yet, and we were seeing a couple of little bumps right in there, and it still is, the energy on the sun is still a little higher than what it normally is. See right here on the C-line base, and it's a 20% chance of more X flares, M flares 65%, C flares 90%, 10% for a proton event. And that's what we're seeing with this proton storm. The solar wind speed, according to this chart, is at 274. Again, that's lower than, I don't hardly ever remember seeing it that low. But I'm getting old and not as sharp as I used to be. Let's take a look at NOAA's predicted KP index breakdown. We're going, if you look, G4 is right here in the purple. Then you can go to a G5, and that may happen. That's a powerful storm, guys. Again, they're saying stronger than what's indicated with a normal X1.9 flare. But if you notice, on January the 20th, we are in the 19th now. We're starting to see some elevated levels. But starting at right there, that's a full day. And this is going to go from a G2 or G1 storm in yellow, quick to the G2, and then jump to a G4, come back to a G2. The red is a G3, and that's going to last throughout the day. And on the 21st, we're still going to be seeing some residual effects. See that? Till we get back into normal. Guys, and this is impressive. Since there's a positive and a negative to impact time, the best part about our impact time is we won't be hit directly on most of the U.S., at least the east half. But you're going to see some amazing auroras. Look at this forecast. You see where the United States is here, and this is tonight's aurora forecast. Going to be very bright. If Minnesota's not snowing, guys, as they're riding tonight, if they're still doing that and protesting, they may get to see that. But again, cell phones and certain cameras, if you're further than that, it'll pick up the glow. And then this is tomorrow night's forecast. Still some residual effects, but nothing like what they're going to be tonight. Now, this is from Solar Ham. They're one of the links on the website. I think most of these are in this video. But yesterday, they were talking about a strong S3 radiation storm. But now in the update, a severe G4 geomagnetic storm watch has been added for January the 20th. Again, that starts today here. Aurora sky watchers at middle to high latitude should be alert. one thing it does say here, it says, even with the S3 radiation storm, energetic particles continue to stream past our planet following the X1.9 solar flare on Sunday. Main impacts, that's why I want to read this, include degraded or blacked out high-frequency radio propagation through the solar regions, and passengers and crews on high-altitude flights may experience increasing radiation exposure. And they already get quite a bit. But, and just, again, think of the astronauts. And I've seen events like this, guys. One event, I can't remember when it was, but it was right when Elon Musk was launching, just getting started launching these thousands of satellites up there, and it knocked a bunch of them out. The wave was so strong, it knocked them out, pushed on them, moved their orbital position and everything. Now, this is the Enlil Solar Wind Prediction Model. They come up with some names, can't they? Anyway, let's play this thing through. You see this bump right there? That is plasma density. That's a very high scale. Usually you'll see this 5, 10, 15, but that's a brick wall right there. Also, this is for a stereo satellite here, but the green ones indicate Earth. Down here, radial velocity, kilometers per second, that is solar wind. And it's showing right now that it's still dropping, or it's predicted to drop below the 320 level, and we're seeing that. Then right here, guys, a brick wall, boom, up to around 500 or 550 kilometers, then jumping up to around 700 kilometers per second, and lasting a long time. You see that? Here's the 20th, 21st, 22nd, 23rd, 24th. The effects of this thing is going to be long lasting, but the density is going to be opposite of the solar wind. Once it hits, it's going to drop very low back down in here. But that's a lot of an impact. And where that's concerning to me is our fault zones for the earthquakes. Now, look, you can see this thing, it comes out very fast. The Earth is in the green dot. The sun is here. This is stereo A. That's what this is indicating here. But watch as it comes out there. Now, notice we're getting the top of it, but that's where the black area is. And that's telling us that's where some of the most powerful energy involved in the CME is. We'll watch it one more time. Let me move this up. Right in there. And I'll tell you what, let's look at it close up. Now let's just move it forward real slow. Again, this is the Earth and the green dot. Same here. This is the plasma density. That's here. This is the solar wind speed or radial velocity. See that? Look at that cloud approaching in the grays. And you can see how thick that is, kilometers per second. In the grays here, guys, they're talking about 700 over here. I think that's way off. As soon as I saw the energized particles, I was thinking that's way off. But when you get into the black and gray, you're going into 1250. That's unbelievably fast and higher. So somehow it's not all lining up. Again, that's why I'm kind of keeping an eye on this thing. Let me move it forward here, stop it there. Let me back it up just a hair. Try to catch that impact time on this model. Compare it to the one last night. We were getting the 7 p.m. East Coast time. Right in there, we're going to be very close to it, both solar wind and plasma density. We'll move forward just a hair. We'll get it pretty right in there. We're going to be in impact at that time. Let me change this out. Now the model is showing at this point, guys, just before impact here in plasma density and here with solar wind speed. And that matches the model from last night, about 7 p.m. East Coast tonight. Now, notice that's just before impact, but I think it's moving, now this is a model, remember. I think it's moving a little faster than what they're saying. So anytime from now to nightfall tonight on the East Coast, watch for things starting to happen as far as solar wind going up. If you go to our website, again, you can link directly to the chart at Space Weather. Scroll down on the left. Top left, it's got a a button that says solar wind speed. Click it, it'll give you the chart that we're looking at, and that's one way to tell. But again, this thing's moving a little bit faster, so the timing is still matching last night's model. Now, I wanted to take a quick look at CERN, our friends there, while we are looking at that, because they directly tie in together where it was originally created for that purpose or not, because we've seen it weaken our shields tremendously. Its magnetic field coming from that 17-mile underground loop of the largest machine ever built is 100,000 times stronger than our Earth shields. So when they're cranking, it's affecting the shields, making them weaker, making them pull closer to the Earth, and lets more radiation in. This is good news. They have shut down their end of the 2025 run. Guys, I haven't looked over here in a couple of weeks, and everything, all the beams are off. That's perfect. This is because we do not want our shields messed up with a G4 magnetic storm if it stays at a G4. Yeah, now the clock is still ticking, but everything's down. All the beams are off, everything. Couldn't be better. I'm proud to see it. We got enough problems on our hand between the solar storms, possibly of tectonic faults, and people being affected by the storm and radiation. So it's a good thing that they're down right now. They'll probably crank back up springtime. Sometimes they'll go out in November, but they definitely reach their goals as far as field luminosity and all of that. And they shut it down for a while. I guess they get a vacation. And when they do that, they upgrade any type of machinery is worn, or like they did last year, they put new plates in to the injection system, I think it was, that allowed them to go much higher. And so that was why we started seeing, if you look at this chart right here, normally it would get about 6,000 gigaelectron volts, which is 6 tera electron volts. It would get to about 65 per beam, putting us at 1,300 tera electron volts. I know it's technical, but they would catch full luminosity at that point. What they use it for, they say one thing, I don't really know. Anyway, when they collide, and what we were seeing this year is much closer to 7,000, so we're getting from 13 tera electron volts up to almost 14, and that's 14,000 gigaelectron volts, very powerful. That's why it messes up our shields. So again, that's a good thing. But guys, we're watching this. You watch it. The updates will be coming. I'm going to be keeping an eye on the solar wind speed. I'll tell you what I'll do. If I forget, someone remind me in the comments. BP, put the solar wind speed link in the comment section, and I'll do it. But I'll try to remember, guys. Thanks for watching. Keep your heads up, maybe down in this case. Anyway, be safe.